Hey there, U8s, Mr. Herman here, and this is exercise 3E, operations with decimals. The learning goals for this one is to understand that multiplying and dividing by numbers by 10, 100, or 1000, etc. can be done by moving digits to left or right of the decimal number. The success criteria for this one is to be able to add or subtract decimal numbers, to be able to multiply decimal numbers, and to be able to divide decimal numbers. Now there's a lot to unpack with this video and with this exercise, and the reason why is because adding, subtracting, multiplying and dividing have its own special rules just with whole numbers. They have their own special rules when it comes to fractions, and now they have their own special rules when it comes to decimals, and we're going to make sure that we know these rules and we're familiar with these rules when we're tackling set questions. With adding and subtracting decimals, we want to make sure that when we add them or subtract them, we have a question that looks like this over here. We have to line them up one above the other for addition. And the second point here, we have to ensure that the decimal points are lined up directly under one another. So in this case here, because these decimal numbers are lined up directly one under the other, and I'm going to zoom up on this, you can see that they're directly lined up. This is fine. So we can go ahead and do the addition. And then when you go ahead and do the addition, the decimal point is still going to remain there. We're going to tackle an example of this. What I don't want to see for both addition and subtraction is something that looks like this, where you see the numbers, there are 4 numbers across and 4 numbers across, and you have to line up each of these numbers together. This isn't necessarily the right way to approach this, because then where are you going to put the decimal number when you add it? And it gets a bit tricky. To compensate for the fact that there are 3 decimal numbers after the decimal point and only 2 after this one, we can just simply add a 0 to make sure that we have now 3 numbers and 3 numbers with the decimals directly under one another, and we can go ahead and do the addition or subtraction. Multiply and divide decimal numbers by powers of 10. When we multiply or when we divide, let's zoom out a little bit. A bit too far. There we go. Oh gosh. There we go. When we multiply and divide, gosh, this is glitching out. There we go. When we multiply and divide, the decimal point appears to move to the right of the same number or to the left of that number, depending on what we're doing. In the case of multiplying, depending on how many zeros there are, as in this case is 13.753, we're timesing this by 100. There are 2 zeros, so that decimal point there moves to the right 2 times because there are 2 zeros. So we just get the same answer, 13753, but move the decimal point to the right twice, and we end up with 1375.3. This will be our answer. If this was, say, 1000, 1000 would have, in this case, 1000 would have 3 zeros. If we're multiplying this by 1000, it will move to the right 3 times because there are 3 zeros. Same thing when it comes to division. When dividing, the decimal point appears to move to the left of the same number of places as there are zeros in the divisor, this being the divisor. So 586.92 divided by 10. I like to think of Beyonce's song Divide Left, every single time you divide it's to the left. Now some of you may remember this song from last year. When you're dividing by 10 or 100 or 1000, you move the decimal point to the left. This is only going once, so this is 586.92. Move it to the left, we're going to get 58.692 as our answer. Now multiplying and dividing decimals. When we're dividing by 10 or 100 or 1000 or multiplying by 10 or 100,000, it gets easy. But when you're multiplying decimals that are the same, there's these 2 rules that you have to consider to make this easy. The first thing, let's have a look at this. 5.73 multiplied by 8.6. So easy to grab our calculators and just put this in. But how are you actually going to do this if you were in a scenario where you don't have a calculator? So initially, you're going to ignore the decimal points and carry out a normal routine multiplication. So let's just pretend that point we'll just put away for now, and that point we'll put away for now, and we'll do 573 multiplied by 86. We do this multiplication, and we end up getting 49,278. Now this is going straight to the answer. Obviously there are zeros that you've got to put in, there's numbers you've got to carry, etc. This is the final answer we get, 49,278. But we don't necessarily want this. We want 5.73 times 8.6. So where do we put this decimal point for this number? So the decimal place is correctly positioned in the answer according to this rule. The number of decimal places in the answer must equal the total number of decimal places in the question. What does that mean? This is saying that the initial question, 5.73, and namely the 73 here, there are two decimal places, or two numbers after this decimal point. For 8.6, there's only this one number, which is 1. When you add these two numbers up, 2 plus 1, this will give you 3, meaning that we need 3 numbers here to be after the decimal point. So our decimal point will go there, or you can see it here, 49.278. So depending on how many decimal numbers there are after the first multiplier and after the second multiplier, that will determine how many decimal places will be in our answer. So in this case, there are 3. Now, dividing decimals, you would think that it will apply the same rule, but it's a little bit different. In fact, a lot different. Not a little bit, it's actually quite different. The decimal point in the quotient goes directly above the decimal point in the dividend. So remember, if we look at a question like this, 56.34 divided by 3, the divisor is this 3 over here, that's our divisor, and the 56.34, the dividend, and we just see how many 3's go into this question here, or this dividend here. Where the decimal point answer is, where it lines up, is directly above. So our quotient, it will directly line up above the dividend, the quotient here, or our answer. 3 into 5, 3 into 6, decimal point, 3 into 3, and then 3 into 4. Now this only happens, in this case, when the divisor is a whole number. When the divisor is a whole number. You'll then get scenarios where, if we get a question like this, 27.354 divided by 0.02, it's hard to put 0.02 as a divisor because it's a decimal number. We're so used to just whole numbers, generally numbers between 1 to 9 as a divisor. So in this case, to compensate for this, we want to change this divisor here to be a whole number. And in order to do that, we have to move this decimal place 1, 2, or in other words, multiply it by 10. As a consequence of this, the dividend also has this decimal place moved to the right twice as well. So instead of 27.354 divided by 0.02, we're effectively doing 2735.4 rather, divided by 2. Now, some of you might be thinking, hold on a second, isn't that just changing the actual question itself? It's changing what it's asking for. We're trying to find out how many 2's go into here, into this dividend. But weirdly enough, this will actually be the same answer as finding out how many 0.02's go into 27.354. And you can use a calculator to actually test this theory out to see if it works. So I've gone ahead, I've got my my scientific calculator. So if we put 27.354 divided by 0.02, we will get the answer of 1,367.7. I'm going to write that down. 1,367.7. Now let's do this again. But this time we're going to do 2735.4, 2735.4, and divide this by 2. 1,367.7. It's the same answer. It is the same answer. We're just changing the proportions of how much we're finding from one to the other, and this is why this technique works. All right, we are gonna try some examples. There are 8 examples all up, so there's quite a few examples that we need to delve into because there's different operations that you can apply when it comes to decimal numbers. So over here we've got 23.07 plus 103.659 plus 9.9. So we need to make sure that this 07 lines up with the next one. So the decimal point is going to line up here. 659 will go on the right. 103 will go on the left. This is being added. And then we're also going to add 9.9. Now we can see a few empty spaces here because this is 3 decimal places. This is our biggest number. So anywhere where you see empty spaces, just fill it in with zeros because they technically mean the same. 9.900 is the same as 9.9. We're just manipulating this so that way we can go ahead and do the addition. Alright, 0 plus 9 plus 0 gives us 9. 7 plus 5 plus 0, 7, 8, 9, 10, 11, 12. We have a 2. Carry the 1. 1 plus 6 plus 9 will give us 16. Carry the 1. Now our answer with the decimals lining up, our answer will be have a decimal place in the exact spot of where it lines up. 1 plus 3 plus 3 plus 9 will give me 16. Carry the 1. 2 plus 1 plus 0 will give me 3. And the 1 carrying over, 0 plus 1 plus 0 will give me 1. So our final answer is 136.629. And that's all there is to it when it comes to adding. For subtracting, so that right there was A. For subtracting, we're doing 9.7. And we're going to take away, now the decimal point lines up here, 2.86. To compensate, because of the 0.86, let's put a 0 here. And now we can go ahead and do the subtraction. Okay, 0 take away 6 we can't do, so we've got to borrow. We've got to borrow 1 from here to make this a 10, turning this 7 or reducing it down to a 6. Now we have 10 minus 6 gives me 4. 6 take away 8 we can't do, so we've got to borrow from our ones unit. This turns into 8, meaning this will be 16. 16 take away 8 gives me 8. Decimal points still line up just like the addition will line up here, and 8 take away 2 gives me 6. So my final solution is 6.84. Example 14, multiplying and dividing by powers of 10. We're going to use skills or knowledge from year 7 and from what I explained before in order to tackle this question here. When we divide, we are always moving the decimal point to the left depending on how many zeros there are. So in this case, when counting zeros, there are 2. So 9.753 divided by 100, we're moving the decimal point twice to the left. Okay, so let's just write this out. 9.753 divided by 100. This will go once. So a decimal point will end up here. Now, there's no number to keep going, so let's just pretend that there is a 0 there. We'll go again. And our decimal point will end up here, just where the equal signs is. So what we end up with is this decimal point, this imaginary 0, and then this 9.753. Let's just double check that this is moved twice. 1, 2, 1, 2, yep. When we have this decimal point and there's no number before it, just put a 0 there. Okay, so that just implies that 0.09753 is the answer. This 0 here, some answers might have this 0 not appear, and this also suffices in the maths world. But for the sake of consistency, I like seeing that 0 there because it's an important placeholder. It shows me that there are no numbers that are meant to be there. Leaving that blank kind of just looks a bit incomplete. That's just my honest opinion. Alright, for B, when we are multiplying by number either 10, 100,000, 10,000, etc., we are moving the decimal point to the right. 27.58. This is going to go to the right. 1, 2, 3, 4. There are 4 zeros here. So 1, 2. And then again, there's no other numbers to keep going. So let's just pretend there are zeros there. 3, 4. So this will end up equaling 2, 7, 5, 8, 0, 0. Now we don't have to write 0.0 afterwards because we know that this is the final whole answer, 275,800. So we're getting 10,000 lots of this, this will be our final solution. Alright, example 15, we're going to multiply these decimals here. Here we have 2.57 multiplied by 3. So let's go ahead and get this up and running. Change this to A. So 2.57, and we're going to multiply this by 3. So we can see that there are 2 decimal places for this first multiplier here, 2.57. There's none for here. So all up we have 2. So let's figure out what this number is. Let's just pretend that this decimal place is not here. So I'm gonna raise that quickly. There we go. So we've got 257 multiplied by 3, and let's just carry out this multiplication as normal. And 3 and 7, 3 times 7 gives us 21. Carry the 2. 3 times 5 gives us 15, plus 2 gives us 17. Carry the 1. 3 times 2 is 6, plus 1 is 7. Now, this solution here, 2.57 multiplied by 3, will give me, because there are only 2 decimal places in the first one, not in the second one, we're counting 1, 2. So our decimal point has to go here, and this will be our solution. Because we're counting 1 and 2, the decimal point must go here, so 7.71 is our final solution. And the second one, 4.13 multiplied by 96. Let's just carry out this multiplication like it's just a normal one without the decimal places. So 4.13 multiplied, got into a bad habit there. I just put the decimal place there. So let's erase this. It's 413 rather, 413 multiplied by 96. There we go. All right, we're gonna do this multiplication. 6 times 3, 6, 12, 18. Carry the 1. 6 times 1 is 6, plus 1 is 7. 6 times 4 is 24. Now we're gonna multiply the 9. We always must remember to put the 0 there because we're multiplying 10s or 90s. So 9 times 3, 9, 18, 27. Carry the 2. 9 times 1 is 9, plus the 2 is 11, carry the 1. 9 times 4 is 36, plus 1 is 37. We're going to add these 2 up. 8 plus 0 is 8. 7 plus 7 is 14. The 1. 4 plus 1 plus 1 is 6. 2 plus 7 is 9. And 3 coming down here. Now, we know that 4.13 times 9.6 is equal to, there are 2 decimal places here, 1 here, 2 plus 1 is 3. So 1, 2, 3, the decimal point has to go here. So our final solution is 39.648. The last 2, example 16, is dividing decimal places. So our divisor here is a whole number, so we can just go ahead and apply our normal division rules, just making sure that the decimal point appears in the same spot as our dividend. So we're seeing how many 4s go into 35.756. So I automatically know that our decimal point has to lie above. How many 4s go into 3 we can't do, but how many 4s go into 35? That's 4, 8, 12, 16, 20, 24, 28, 32. So we end up with 8, 33, 34, 35, so 3 remaining. Alright, so we carry this 3 over to here. Even though this decimal point is here, it makes no difference. We just still carry that 3 over to there. How many 4s go into 37? Try again. 3, 6, 9, 12, 15, 18, 21, 24, 27, 4, 8, 12, 16, 20. I don't know what I was getting. 4, 8, 12, 16, 20, 24, 28, 32, 36. So this is 9. This goes up to 36. With 1 remaining, 37. That 1 goes here. 4 into 15. 4, 8, 12 is 3. 13, 14, 15 with 3 remaining. and 4 into 36, 1 again. We have no remainder or leftovers, so our answer or our quotient is 8.938. So this would just be like a normal division. We've just got to compensate with that decimal point here. But now we get to our last one. That was A. So now we get to our last one, B. And we have this situation where we've got 0.03 as a divisor. We don't want this. We want this to be a whole number. So we need to move this decimal point 2 times to the right to get a divisor to be a whole number of 3. But as a consequence, we've got to do that to dividend as well. So this will be 6413.7. And remember, this and this mean the same thing, but it's now easy to carry the division because our divisor is a whole number. So we're seeing how many 3's go into 6413.7. And we go ahead and just carry this out as normal. 3 into 6 twice, no remainder. 3 into 4 once, 1 remainder. 3 into 11, 3, 6, 9, so 3, 2 remainder. 3 into 23, 3, 6, 9, 12, 15, 18, 21, so that's 7. 2 remainder. And 3 into 27 is 9. So our answer or quotient is 2137.9. And that concludes this. I was trying to get this under 25 minutes. I did it under 21, which is awesome. What questions do we need to do? So here's the textbook. This is for exercise 3E, so page 139. And what questions we're attempting is over here, 1, 2, 3, and 4. Don't worry about the right hand columns for question 2. And every second question for 3 and 4. So 3A and C, and 4A and 4C. Then the next page, we're just focusing on question 5, 6, 7, and 8. All down here, just the left hand column. Don't worry about the other questions here. And that will be it regarding questions. Okay. Make sure that you get all the set notes that you need to into your theory book and the exercise book for your questions. Till then, see you in the next video. Bye bye.